Space Chronicles in partnership with the European Space Agency.
Mars, the red planet, our fascinating and mysterious neighbour. Satellites and probes have been studying Mars since the mid-1960s. And yet two fundamental questions still remain. Where is the water that once flowed on the surface? And is there, or was there ever, life on Mars? Europe's Mars Express mission set out in 2003 to help find the answers.
I think the chances that there may have been life early in the history of Mars are good.
Mars is a planet which is, I would say, very much alive.
Can life go underground and disappear? Can water go underground and disappear?
To answer those questions, data from Mars Express is being used to compare Mars with Earth. There are some obvious differences. Mars is half the size of Earth, and the surface environment is harsh. The average Martian temperature is minus 55 degrees Celsius, and the thin atmosphere, made up of 95% carbon dioxide, offers little protection from the sun's rays. The atmospheric pressure is just 1% of that on Earth, far too low for liquid water to remain on the surface. But there are some important similarities.
Mars shows a variety of geological phenomena like volcanism, like polar caps, like transparent atmosphere, like glaciers that are only shared with the Earth. These are the two planets in the whole solar system to have these features.
Is this a place where primitive microorganisms could survive today? Mars Express is doing some detailed detective work to find out. The 7 instruments on board include the Marsis radar, which searches for signs of water, and the HRSC camera, which is responsible for the stunning pictures of the surface. Here we see a mound of water ice which lies in a crater near the Martian North Pole. The results have helped us piece together the early history of Mars.
About 3.8 billion years ago, the surface of Mars had significant episodes of liquid water on its surface. But suddenly at that time, there was a big climate change on Mars. So water was no longer possible on its surface, and presumably it took refuge below the surface. This is what we are also trying to look with Mars Express, that allows us to look below the surface down to about 5 kilometers deep. And we have indeed identified some layers of water ice, not liquid.
As the people of Rome will tell you, we humans enjoy la dolce vita. We like our creature comforts, not too hot and not too cold. But research has shown that parts of Earth we once considered sterile are indeed home to life. Microbes have been found living in rocks, in freezing deserts, in boiling volcanic pools and ocean trenches. Italian scientist Vittorio Formisano believes a common gas, methane, could help us draw a link between life on Earth and what may be on Mars.
You know, on Greenland has 2-3 kilometers of ice on top. And they have been doing a study with the depth in the ice. They have found that in the bottom of the ice, in the last few hundred meters, were extremely rich of methane, and there were living bacteria there. These are bacteria that don't need atmosphere.
Formisano's team runs the PFS instrument on Mars Express. Its sensors have found methane in the Martian atmosphere. They're now trying to work out exactly where the gas is coming from. It could be a vital clue, as methane is strongly linked to life on Earth.
Methane cannot stay forever in the Martian atmosphere. On Mars, it was said that methane had a lifetime of the order 300, 600 years. That implies that methane is destroyed, therefore there must be a source of methane. Now, on Earth, it's well known that the source of methane is mostly life.
But life isn't the only possible source of methane. It could be coming from volcanic activity, mineral reactions, or a cometary impact. It's important not to jump to conclusions.
Science is not made of feelings. Science, you must demonstrate things. And for the moment, we have demonstrated methane is present. Even if methane is generated by life, you need to go on Mars to search for life, to find it and to study locally.
The next European Space Agency mission to Mars aims to do just that. ExoMars is due for a launch in 2013. It'll put a lander carrying a mobile automated lab on the surface of the planet. The project's primary aim is to search for past or present signs of life in the top 2 meters of soil.
The most important element of the rover is the drill. And this is because we believe that in order to address the scientific objectives of the mission, we have to look in the subsurface, underground. We're looking for organic molecules that we can either associate with processes that are important for cellular life, or we're looking also for residues, organic residues of possible life molecules that corresponding to life that may have disappeared a long time ago.
NASA's Phoenix lander will arrive on Mars later this year with the same aim, drilling into the ice and soil to check for life. Excitement is building among Mars scientists.
That would be mind-boggling. It would be excellent to find that life is not just confined to a planet, and for the first time have proof. And after that, trying to understand if the genesis or the process by which that life came to be on Mars was similar to the one we had on Earth.
Perhaps one day the origins of life on Earth will be explained by what we've learned from Mars.